All right, hi guys. Day 2 of our acid-base calculations. Today we are talking about something called pOH. So if you read the slide before this video, you know that pOH and pH, which is what we talked about yesterday, technically work the same way. pOH just uses our OH minus or our hydroxide concentration instead of our H plus concentration. So a lot of times we'll use pOH when we're talking about bases, because if you remember back to when we first started, we said that bases are going to give off that OH minus, right? And then our acids are going to give off the H plus. So when we're talking about acids, it's a lot easier to talk about and calculate an H plus concentration and a pH. But when we're talking about our bases, we're talking about OH minus. So it's a lot easier to talk about our OH minus concentration, or how much OHs there are in our solution, and then to talk about our pOH. Tomorrow we're going to look at how we translate between the two of them, because really we can talk about either one with either acids or bases. So we'll look at that translation tomorrow. Okay. So if we look up here, I've just written down the highlights from that picture on the last slide. If we're looking at something that has a pH of 14, okay, at the very top of that pH scale, yesterday we talked about that being sodium hydroxide, it would have a pOH of 1, and it's going to be very, very basic. So our low pH numbers between 1 and 7 are going to be our basic solutions, and our high pOH numbers between 7 and 14 are going to be our acids. So that's opposite of what we said yesterday with pH. Okay? If we're thinking about pH, the closer it is to 1, the more acidic it is. But for pOH, the closer it is to 1, the more basic it is. For both of them, 7 is still our magic number. 7 is neutral, means that there's an equal amount of H plus and OH. So it's not either acidic or basic. Okay? So let's look at some calculations for how we can figure out our pOH. If you caught on to the pH calculations yesterday, you will be just fine with these. They're essentially the exact same thing. So here are our two problems for today. The first one says the OH minus concentration is 2 times 10 to the negative 9th molar. Find the pOH. So remember our calculation from yesterday, we used that negative log. We're going to do the exact same thing today. So our pOH is going to be equal to the negative log of our OH minus concentration. Notice that's almost identical to what we did yesterday, except for yesterday this was a pH, and this was the log of H plus. So we've just switched both of these to OH. As long as I switched both of them, it still works the same way. So my pOH in this case is equal to the negative log of 2 times 10 to the negative 9th. Remember, really small number, negative exponents, means that we're moving our decimal point to the left, so we're going to make this a really, really small number. When I put this into my calculator, I'm going to do negative log of 2 times 10 to the negative 9th. Enter. So I get a pOH of 8.698 or 8.7 as my pOH. So if I'm thinking about my pOH scale, right, a number that's greater than 7, between 7 and 14 on my pOH scale is going to be acidic. Okay. Now let's look at my next problem. This one says the concentration of OH minus is 2.5 times 10 to the negative 6. Is it an acid or a base? Okay, so I have to calculate my pOH to figure out if it's acidic or basic. So pOH equals the negative log of my OH minus, so negative log in this case of 2.5 times 10 to the negative 6th. Get out my calculator here. Let's put that in. So negative log of 2.5 times 10 to the negative 6th. This one is going to give me a pOH of 5.6. So remember my cutoff is 7. So 1 to 7 is basic. And then 7 to 14 is acidic. So in this case, I'm lower than 7. So this is going to be a basic solution. So this is going to be an example of a base. Okay, on the next slide, you've got a couple of practice problems, just like yesterday. They're all going to be based on calculating pOH. So try the practice problems out first. The slide after that has the answers, so you can check and see how you did. And then there's an understanding check that has 2 problems that are very similar to the ones that we just did here. Okay. Again, tomorrow we're going to look at how we convert between OH and H+, so that we can kind of talk about what this all means in a bigger picture instead of just the calculations. All right, see you tomorrow.